Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video, we are covering CCNA CyberOps, and this is chapter 11, security monitoring. Now, when we learned routing and switching, you have learned ACLs, hopefully, and you are very familiar with that, and they are great. So, when you configure something and you see it working as it should, and you see that something has been blocked as you wanted it, that is great feeling and so on. But ACLs can give you a false sense of security if they are overly relied on. So attackers can determine which IP address protocols and port numbers are allowed, and they can spoof their address to the ones that they are allowed. They can do that. I can change the address. I can spoof. I can create a packet that it says, okay, well, that's the IP address, the one that you allow it, and that's the port number, and I can forward it. So how they can find out what IP addresses and what ports are allowed using port scanning or penetration testing, and through other reconnaissance forms. So attackers can craft a packet that is used that use spoofed source IP address application can establish a connection on arbitrary ports. So for example, some of the ACLs we create here, we can see it on the side here. We have, for example, access list 112. So you should really know what the ACL is. Is standard or extended? Okay, extended. I'll stop asking questions. So permit ICMP any to any. So we're going from any source to any destination, and echo reply. So we are permitting. So rules on all one ICMP traffic from the internet. So ICMP any from any network coming to any network, echo reply. So we allowing this reply to coming back from the internet. Permit ICMP any to any source quench. It is a message from a host computer to another, telling it to reduce the pace at which it's sending packets to that host. Another message will be, for example, unreachable. So these messages are generated by the router to inform the source host that destination unicast address it is unreachable. Then we have parameter problems, like messages is generated as a response for any errors not specifically covered by another ICMP message. And last, for example, packet too big, if a router cannot forward a packet because it is larger than MTU of the outgoing link. So some of these that we have them by default, some of the ICMP messages that we allow in our network. Like we said earlier, the network address translation and port address translation, they do complicate security monitoring because they change an IP address, but as well as they can change the port number. So remember, we had network address translation, different types, static NAT, that just changes from one IP address to another IP address. Then we have a dynamic NAT when we change many IP addresses to a few IP addresses, and PAT. So we change an IP address as well as a port number. So multiple IP addresses are mapped to one or more public IP addresses that are visible on the internet, hiding the individual IP addresses that are inside the network or inside the addresses. So for example, say that we have, let me write here. Say that this is our LAN, LAN. So local area network here. So as we go, that's called inside network, and we have an outside network. So all these IP addresses on LAN, they're called inside local address. And the address that we translate to, for example, say that we translate to this address of the router, is inside global address. It's still our address. That's why it's called inside global address. The address that we go to, for example, say that we go to this address, that's called outside local address. But outside local address, it does get translated to outside global address as well. So we don't really know. This address is going to be the same as this address. So local address, same as the global address. So as a packet come in, for example, from this one, let me clear that. So they come from 192.168.10. So 192.168.10.10. They come into this router. The router will change them or will translate them, that address to another address, to the global address. And as they go to the then they go to the internet. The problem is that as they're coming back from the internet, it's hard for monitoring purposes to see, okay, what address has gone to what address. Encryption, encapsulation, and tunneling. We like the encryption. Encryption is to hide our messages from man-in-the-middle attack. But the attackers can use the encryption as well. So encryption, what we do with encryption is we are actually jumbling our messages, and we have a key. I have a key, you have a key, and I encrypt my message with that key, and nobody else can understand it. So if there's a man-in-the-middle attack and they find out our messages, they won't be able to make without the key. They won't be able to decrypt what we said. But the problem is the attackers, they can establish encryption with a command and control center, so they can exchange messages encrypted. And well, as us, we are actually monitoring, and it's hard for us to see what sort of messages are there. So HTTPS does encrypt and can present challenges for security monitoring by making packets data unreadable. So encryption, it is used as a part of VPN technologies. In a VPN, a commonplace protocol like IP, it is used to carry encrypted traffic. A similar technology can be used to create a virtual point-to-point connection between an internal host and a threat actor device. So malware can establish an encrypted tunnel that rides on a common and trusted protocol, and is used to exfiltrate data from our network. So for example, password, username, password in our database. Peer-to-peer networking and Tor. So in peer-to-peer networking, hosts can operate both as a client or a server roles. It is three types of peer-to-peer networking that we have. It's file sharing, process sharing, and instant messaging. Now, file sharing and peer-to-peer networking, for example, if you're familiar with torrents, for example, before, when the movies were not, they were available from the internet, and people, they wanted to watch them, download them illegally and whatever, they would download them from the peer-to-peer networks. So one device, for example, many devices had the same movie, they were sharing it, and you were downloading pieces by pieces from many devices. So you could be downloading one movie from, say, hundreds of other devices, so 100 other servers. So you come in pieces, small pieces. Well, that's bad, because most of them, they used to be malware anyway. It was a malware infection in there as well. In a file sharing, peer-to-peer files on participating machines are shared with members of peer-to-peer networks. Example of this, there would be a popular, for example, Napster on Contella. Bitcoin, it is a peer-to-peer operation that involves the sharing of distributed database or ledger that records the Bitcoin balances and transaction. BitTorrent is a peer-to-peer file sharing network. Anytime the unknown users are provided access to network resources, security, it is concerned. So file sharing, anyway, peer-to-peer file sharing is a bad thing anyway. If somebody's getting from torrents lots of stuff, lots of messages, and is downloading a movie or whatever, it's bad. Another thing is, could be a process sharing. Now, process sharing, it is a way to share the process or combine the power from many processes. So for example, if you need to job that you have to do, and one computer, one processor doesn't have enough power, what you can do, you can have a process sharing. So you can join many computers together, and then obviously you can have a super machine. And instant messaging is another peer-to-peer type of networking. Now Tor browser, it does allow you to surf the internet anonymously, and then it is used for a lot of hackers, a lot of black hat hackers. Because they don't want to know what they're doing on they don't want you to know what they're doing on the internet. Now it is used on dark web a lot. Dark web is a place where you can buy, sell lots of illegal stuff, and it's not a good place anyway. It is used at Tor, and Tor, what happens is very interesting with this. It's kind of like, let me put this through. The Tor network allows users to browse the internet anonymously. Users access the Tor network by special browsers, so you need to download and install these Tor browsers. When a browser session is begun, the browser constructs a layer end-to-end path for access to the Tor server's network that is encrypted. Each encrypted layer is peeled away. Okay, let me explain what's happened. What is this? So kind of like, for example, say this computer here wants to talk to this server here, right? And on the path, there is a lot of routers to the destination. But they construct, for example, encrypted way from the source to destination. So which only the destination can decrypt that. Well, from here to here. So that will be encrypted. This router will not know the end destination. Where is it going? The only path they will know is where to send it to the next router. So they will say, okay, well, I got a packet and it's used to Tor. So each end device is becoming like a router here. So this, for example, opens and says, okay, well, I can send it from here to here only. That's it. I don't need to know the rest. Where is it going? Right? And this router here does not know where is it coming from. It just knows, okay, well, got a packet, and if I opened it and I need to go here. And this router opens it and says, okay, well, it doesn't really know where is it coming from. It just knows that it's coming from this device and it needs to go here. So nobody knows the path from the source to destination. So each encrypted layer is peeled away like the layers of onions as the traffic traverses a Tor relay. The layers contain encrypted next hop information that can only be read by the router that needs to read the information. In this way, no single device knows the entire path to the destination. The routing information is readable only by the devices that do require it. Okay, last thing, load balancing. Now, load balancing is a great thing. We love load balancing. If we can send the path, we can send the data through two paths, reduce traffic, or send or reduce the workload for one device and increase our throughput. Well, we send it through two paths, but that causes a problem with the monitoring. So load balancing involves the distribution of traffic between the devices or network path to prevent overwhelming network resources with too much traffic. If redundant resources exist, a load balancing algorithm or device will work to distribute traffic between those resources. This can result in a single internet transaction being represented by multiple IP addresses on the incoming packet. This may cause suspicious features to appear. In the packet captures, because you are kind of receiving the packet from two different IP addresses, same conversation. Thank you for watching this section, 11.1 Technologies and Protocols. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi. Next video, 11.2 Log Files. Bye bye.